failure mode and effects analysis, which is a proactive tool to identify risks in advance. This can either be a production process or for a product design or even for a logistic process. But how does it work? Let's make an example to understand this better. So this is a PFMEA template of AAG 4th edition. Our first column is process, where we identify the process steps respectively. The input is process flow diagram. So basically we identify each operation in the process respectively here. For the example, let's go through with a single line item and let's say packaging operation. And the next column is requirements, where we identify the requirements of this specific operation. In other words, what we expect from this process step. If it will be a technical product with some dimensional requirements, we will identify the dimensions with their tolerances here. But for our packaging operation, let's say we expect 10 parts per box. This is the requirement of this operation. We can also identify other requirements if we have, such as no contamination, but let's continue with a single line item to understand the logic of PFMEA better. And the next is potential failure mode, where we identify the failure modes of this specific process step. We assume everything before that process was okay, and we just focus on this specific process step and think about what can go wrong. So our requirement is 10 parts in a box. If it is 9 or less, then this is a failure mode, right? So we can say missing part, or let's say incomplete box, in bracket, missing parts in box. Perfect. And next column is potential effects of failure. So here we imagine that the failure mode occurred. What would happen? What will be the result of it? If you put 9 parts to the box instead of 10, what would happen? What is the effect of this failure mode? For our example, if customer doesn't receive all parts in time, the production line can stop. So let's identify like customer production line stoppage. This is the effect. Now we will rate this severity by considering this potential effect of failure mode. Let's bring this severity table. So we rate this out of 10. 10 is very bad effect and 1 is no effect. And in this table, you also see 2 different description columns. First is for the product effects and second is process effect. For our example, if we send incomplete box to the customer, it will be about process effect, not a product function. So we should rate 8 because there is a risk of line shutdown. So it is very, very high. Let's say 8. Next is classification. This is where we identify the special characteristic which can come from product design or in some cases process. This characteristic vary depending on the organization and its customer. So for example, while Ford company uses CC and SC and Renault use SR characteristic, they are safety and regulatory. So it's quite depends. We will keep blank, which means no classification for these specific requirements. Next is potential causes of failure. Here we identify the reasons for the failure mode. What could cause this? Our failure mode is missing part in packaging box. It's basically incomplete box. So what could cause this? If we identify for this example, let's say lack of training can be one of the causes, and we can also identify another cause. So let's identify for this, let's say lack of visual instructions. Perfect. And next is occurrence. Here we identify the possibility, the occurrence of these causes. But the best practice is to identify prevention controls at first, because we will consider prevention controls as well for the occurrence rating. So here in process controls prevention, we simply identify the preventions to avoid these causes. So the first cause is lack of training. What can we do this? What can we do to mitigate or avoid this? So let's say operator periodical training. So this just address this cause. And we can also identify standards operating instructions, let's say in the packaging line, just to reduce the possibility of lack of visual instructions. So these two controls address those two potential causes of problem. Now we come back to occurrence rating. Let's bring the occurrence table. Here is 1 is very low, which means very unlikely to occur. But on the other hand, 10 is very high, which is minimum 10% of failure rate. When we rate the occurrence, we focus the cause of the problem and preventive actions that we identify. Also, previous defect rates of similar parts and processes. So for our example, let's say it is a low possibility and the occurrence is 3, which is low for both. Next is process controls detection. Here we assume that failure is occurred. Regardless of the occurrence rating, it just occurred. How could we detect this failure mode or the error, which means the cause of the failure mode? Can we make a visual control at the same time or after the process, or maybe a barcode control, which is the robust way for packaging operations? So let's say for this example, operator visual control for each box in the station. So this is basically valid for both because here we are just addressing this potential failure mode. The next column is detection rating. So we will rate the detection control out of 10 according to the detection ranking table. Let's bring this. 1 is if we eliminate the cause of the failure mode at the source, which is the most proactive approach, we would rate with 1 as it is an error prevention. And the 2 is if we can detect the cause before it becomes a failure mode, where it is possible, detection rating will be 2 in that case. And 3 is detect the failure mode at its source. So if we detect the failure mode with automatic controls in the same station, then it will be 3. So one of the important points here is understanding the difference between the failure mode and error. Error is cause of failure mode. And another important point here is to consider where you detect this. Before it becomes a problem, or at the source, or at the post-process controls, all this affects the detection score. So now, for our example, since it's just a visual control by operator but at the source, I believe we can rate 7, which is the detection in station by operator through visual, tactical, and audible means. So let's identify 7. We can also identify 7 here because it is the same, and we can also merge or just copy and paste. Perfect. And the last column of the main part is RPN, risk priority number. Here we write the multiplication of severity, occurrence, and detection. The higher the RPN, the higher the potential risk. So for our example, it is 8 multiply 3 and 7. So it equals 168. The RPN is 168. This is a high number for the automotive industry, to be honest, but it depends on the product and process type. So, for example, if you work with the sensitive parts like metal parts in a stamping operation, 168 is considered too high, but for a process like iron casting, where more variation is expected, it might be acceptable. And some companies also define a threshold. So, for example, if it is over 50, then an additional action here is required to reduce this. So, the RPN helps to prioritize risks. However, RPN is not the only decision making tool. So, even if the RPN is low, a high severity rating here, especially in safety and critical cases, for example, it might still require additional action here. So now we completed the main part of a one-line item. Now you also see a following section where we identify the recommended actions. So here we identify more actions to improve these line items when it is necessary. So for our example, if you want to decrease the detection from 7, let's say, to a lower number, we should put more robust actions here. So let's continue with the same example, and if we adapt the camera control for each box, so basically camera will count the number of parts automatically for each box, and if it is fully okay, the system will print the box label. This is a very good automatic control because without the box label you cannot ship the parts to the customer, and the camera will only let printing the shipment label if the box is fully complete. Let's write here automatic camera control in bracket connected with label printing. An action will be applied, will be set up by, let's say, meta in 31st May. So the following section is action taken section. We populate here once the action is done, once the action is conducted. Or here we can just say it is ongoing at the moment. And regarding the new rating numbers, severity is still same. It is 8. Because if it happens, result is same. We didn't change the effect of failure mode. To be honest, it is almost impossible to change the severity unless there is some design changing. And next is occurrence. Occurrence is same. We didn't reduce the possibility of lack of training and lack of visual instructions. They are still same. So it is 3, but detection, we change the detection because the failure mode is detected at source by automatic controls now. So it is different than the visual controls. So according to the detection table, now it is exactly causing the requirement of 3. So we can just rate as 3. These actions are also applicable for those. So now basically we reduce the RPN numbers from 168 to 72 with an automatic control by reducing the detection control rating. So operator can still miss a part in this operation, but it will be detected in the same operation by camera and the system will be logged because label will not be printed. So it is a very good example of rating 3. That's it. So now we understand the basic logic of BFME with a simple packaging operation. Thanks for watching. Please don't forget to subscribe to see some more video like this. And please check this video description and you will see a link to download this FMEA template for free.